So what we're doing is over on the far right of the screen, which we call the plant-induced method of using RNA viruses to then have the plants make the antipathogenic, antibacterial products themselves. So what that is introducing a virus. In the case of what we're focused on primarily for citrus, it's a relatively benign CTV virus that has been modified. So when that virus is introduced into the plant, it will produce antipathogenic products. So basically a virus, once introduced into a plant, will go into the plant and go throughout the cells, in this case for CTV, the phloem cells, phloem companion cells, and it will basically trick the plant into replicating itself. That's what viruses do. And so what we do is have a method for when the plant is replicating the virus, it's also producing the antipathogenic products that we have instructed it to do. So in the particular case of our product, as mentioned, there's a citrus tristeza virus. This is one which naturally doesn't move from tree to tree. So it has to be introduced into each tree, and I'll explain how that is done a little bit later. And that's been modified to produce a spinach defensin peptide, which we've screened hundreds of different peptides through Texas A&M, and found that these versions of natural spinach defensin peptides work the best so far out of any peptides that we've seen. And so when the virus is introduced into the plant will basically, as it's replicating the virus is making the peptide as well. And the peptide then will accumulate in the plant and will go after the HLB. So one big advantage of this approach is that you only have to introduce the virus once, and then the virus will replicate for years and years within the tree. We've had studies going up for now for almost 8 years, showing that the virus is still in the tree, still replicating and still making the defensin peptides over this period of time. And just a little bit about defensin peptides. So these are copied directly from what's in spinach. Spinach is one of the least allergenic foods out there, and the amount of peptide that's being produced is relatively small, at least 100 times less than what you would get from eating spinach. And we've done a large amount of toxicology studies, and it is currently in front of the EPA for a final approval. And just to emphasize again, this is not a DNA technique. This is not a technique that at all impacts the genome of the plant. So again, like the COVID vaccine analogy, you're putting this modified virus into the plant, but it is not impacting the DNA. It's not even going into the nucleus of the cell. It's just sitting there in the cell's cytoplasm, replicating and doing its thing and making the product. Now, one very interesting side note of this is its compatibility with oxytetracycline. So based in the United States and Florida, the vast majority of trees now are getting injections of oxytetracycline every year, depending on the age, 1 or 2 injections. And that's working well to suppress the CLAS and is helping the trees and helping the growers to have a more economic production. Our product will work in tandem, synergistically with that. And the reason is that what we're producing, spinach defensin, is an antimicrobial peptide. Oxytetracycline is an antibiotic. These both work very differently, and this is some graphics that are from the human medicine side, since there's been decades of research of how you combine antimicrobial peptides that can break apart cell membranes, break apart biofilms, and antibiotics, which go and directly kill the organisms and suppress them. And by doing this together, we have data showing they actually work better together. So we're working closely with the citrus growers in Florida, and the recommendation is to continue to use the oxytetracycline and to use our product as a way to get a multiplicative effect. One advantage we also have is, while oxytetracycline and other antibiotics will incur resistance, and in fact, in Florida, you can only use right now the product every 2 years, and then you have to let it have a year off in order to reduce the antibiotic resistance buildup. It won't eliminate it, but it might delay how long you can go with antibiotics before the resistance happens. The trees are then left, defenseless for that 3rd year, which is coming up, since it's only been allowed for the last 2 years. And so with our product in there, we expect to have a more stable performance even during the off year for antibiotics. So what are the results that we're showing? We've been working with US Sugar, who has been promoting this technology for a long time. And we have a number of long-term field trials. And with our current product, we're getting fairly similar results to oxytetracycline. For younger plants, for the early injections of oxytetracycline, they can get about a 30 to 40% yield improvement. For our product, we're also seeing a similar amount, but over time, the results do lessen. So hence one of the needs to keep both products, oxytetracycline and our product, in the plant. But we're working on our next generation, where we've gotten significantly more defensin peptide being produced, anywhere from 10 to 100-fold increase, which in our early testing on our model plants is showing significantly better suppression of CLAS. We're currently testing this in citrus against HLB now. We hope that this product is going to be significantly better than just a 10 to 30% reduction. And what we're trying to do over time is to get to a 100% reduction. We think between this latest generation with additional antimicrobial peptide, and combining it also with small interfering RNAs, which we can do in our single vector, so our single product, we'll have multiple inserts targeting, some will be making the peptide, others will be making small RNAs, which others have talked about, which can use to be targeting host susceptibility genes and other genes. And so we are looking at combining those all into a product for Gen 3. So this is a product that's been developed for the past 15 years. It's been generating a lot of regulatory data. The regulatory process in the United States is not quick. However, we have a USDA approval for commercial use. We have very positive environmental impact statement from the USDA. And we applied for our final EPA approval back in January. This is based on data sets that took over 10 years to develop. And we're actually looking for, if things go on track, to have the product approved in 2025, which would allow a 2026 commercialization. So we're at the end of a very long and arduous process, and we're in touch with other countries as well, and trying now to see how we can use the USDA EPA approvals that we're getting to try to fast track this into other countries like Brazil and Mexico, to see what we can do there, and especially with the focus on the Gen 2. So we are, a 2026 for the Gen 1, but we have to repeat some of the toxicology and other work for our Gen 2. So looking at a 2028, and then hopefully following up in 2029. So products available in the near term, and hopefully some real game-changing, and we're targeting, closer to immunization products later. So I think, based on what we've heard at other talks, we've got a lot, we have a very different approach. There are other approaches, and hopefully, in the next 5 years, some of these really start to have an impact and have approvals and are ready to go. One word about how our product is delivered. I mentioned you have to put this into every tree. Well, our method of doing this is one which is, I think, very elegant and will have a minimal impact on the distribution supply chain currently being done. So if you think about our product, it's a citrus tristeza virus. Citrus tristeza virus has been introduced into trees for many decades in Brazil and elsewhere in order to provide some cross protection against more virulent forms of the virus. And so we're really using that same method of getting our product in. So in terms of how citrus trees are produced, as I'm sure most of you know, it starts at a nursery with mother plants, which are going to determine what the fruit variety is going to be. They're going to take budwood from those mother plants, use them as scions, graft them onto a seed-grown rootstock at the nursery. Then it will be at the nursery from 12 to 15 months before being sold to growers. And so just like you would provide cross protection with CTV by inoculating just the mother trees, which, in a nursery, this might be a few dozen trees to represent the main varieties. And of the main varieties, you might have a few dozen more to produce more material. This material can get expanded and then be used to produce millions of trees at the nursery. But it all starts with just a very small number of mother trees. And so we go in and just inoculate those mother trees, which is a one-time thing. After about 2 to 3 months, the mother tree will be systemically infected with the CTV virus, our virus. And then as the materials is used from those mother trees for grafting and for producing the nursery trees, it will have our product in it automatically because it's taking material which has our product in it. And as you graft it and as that tree grows, it will have our product in it. And as it's sold to the field, it has our product in it. So essentially, the cost to basically deliver our product is not, and the effort is not going to be any more than is currently being done in the current nursery process. It just sort of automatically flows along with that process, other than that one-time process where we inoculate the mother trees, which can be done in a few days. And that's a one-time process, so call that a negligible cost. And so I think it's a fairly elegant way to get our product into the field. And so to summarize, we are basically have a non-GMO a product that produces a non-GMO tree, does not impact the genome of the tree, and will currently enhance yields for trees suffering from citrus greening, and over time, hopefully provide immunization. No detrimental impact to the tree or to the fruit, synergistic with OTC. We only have to do a single application. It's compatible with all trees, so a single product. Citrus tristeza will infect nearly all types of citrus, so it will work with all varieties. Very advanced in the regulatory process in the US with USDA approval and EPA approval expected in the next year or so. And for our model, we're looking at charging a subscription to growers. So we don't want to hit growers with a large upfront fee because we know how sensitive that can be. So we want to provide a modest charge, which will be a small fraction of the benefit provided by the product, and a significantly lower cost than is currently being paid for the annual OTC injections. So we think we can be able to provide a lot of value for a relatively small amount of cost.